Question 4. Sketch the graph of g of, you could say a, technically it's alpha, but not a massive deal. I'm going to use alpha. G of alpha equals sine of alpha over the domain negative 3 pi is less than equal to alpha, which is less than equal to pi. Okay, again, just trying to look at different things you can get hit with and just slowly introduce you to them so you can feel comfortable with them, and also so you can realize that there's nothing really too different happening here, even though it looks weird. Let's copy it down. So G, and the way you can draw alpha if you're not used to it, you can kind of just draw like a cursive A. You'll see a lot of people draw it like this. So you start here, you come down and then up and around, and like that. It's kind of like a fish. I picture it like a fish sometimes. It's also like 3/4 of the infinity symbol. So you can draw infinity like that. And so it's like drawing infinity. You just don't finish that end bit. This is probably a little bit too extreme. You want the tail to be the smaller bit. Something like this, anything like this is fine. Or the cursive A if you prefer. Okay, so G of alpha equals sine of alpha. Nice. Also, what is alpha? It's another Greek letter, just like theta. So we often use alpha and theta for angles. Theta is like the primary one, but if we need a secondary one, we often use alpha. Like if we're already using theta, we might use alpha for another thing. So if I have a triangle, I might call this angle theta, but I might call this angle alpha because I already used theta over here. Another one you might see is beta, which is like a B. That's a longer thing here, and you kind of draw it on a slant if you want to be perfect. Anyways, so that's what alpha is. That's why we're seeing it pop up here. But don't be surprised if you just see other letters like sine of R. It's less common, but I just don't want you to freak out when you see something different like that. It doesn't necessarily mean anything crazy. All right. So G of alpha equals sine of alpha over the domain just means between negative 3 pi is less than equal to alpha, which is less than equal to pi. So the different thing about this one is now we're dealing with negative domain and positive domain at the same time. It's not that much harder than the previous questions. It's just like having this question here and then putting, you just join it with a positive question like the ones we did in the last lesson. So it's nothing too crazy. Because now we need positive and negative x values, or obviously it's alpha here, but it's on the x-axis. I'm just going to put my y-axis right in the middle. Like our halfway point for x is going to be in the middle. If you're really paying attention, you might notice that we're going to need more negative than we do need positive. So you could maybe move this over here and draw it here. That way we have extra room for the negatives there, and we don't need all this room for the positives. So if you want to do that, you can. But if there's too much kind of going on, while you're still getting used to it, or even once you do get used to it, you can just put this in the middle. I don't know if I would do it for these ones because we only need negatives there, and so we might run out of room. Like especially if we're trying to fit like 4 pi and just from here to here, it might start getting pretty squished. So it's worth thinking ahead, but it's completely fine to just do it in the middle. And if you do it in the middle and then you get kind of squished, you can easily just redo it. Once you get used to it, it doesn't take that long to graph them, even though it feels like it takes a while. All right, I'm going to start yapping. X-axis like this and this. Beautiful. Okay, now the biggest number we have is this negative 3 pi, because this is only pi. So we need to make sure that over here, we call that negative 3 pi. Because if we said this was pi, then obviously this wouldn't fit. So we do that, and then that means that a third of the way here will be pi. So we need to mark them in. Thirds are kind of tricky, but I'm going to go roughly about halfway and then go a little bit over. And that should be a good enough estimate. Again, if you're using graph paper or you have a ruler, you'll be able to be more precise with that. This should do for now. So this would be negative 2 pi. This would be negative pi, 0. And then now that we know this distance is pi, we can come out this distance and make this our positive pi. And then for completeness, we'll keep going and mark 2 pi and 3 pi, but we're not going to use it obviously because our domain is between, it only goes up to positive pi. Okay, now when we have negatives and positives, I would start with the positives because we're more used to it. I put it here because obviously sine of 0 is 0. Okay, now remember something interesting happens every quarter and the full sine wave would be up to 2 pi. So we need to mark in the quarters. So pi on 2, 3 pi on 2, although we're not going to use this one. But we might have to come in, now that we know we do have to mark these, we don't have to mark them all. May as well do it now. 3 pi on 2, 5 pi on 2. To get used to this, you go like this is pi on 2, 2 pi on 2, 3 pi on 2, 4 pi on 2, 5 pi on 2. Just count your way around like that. And this will go similarly, negative pi on 2, negative pi, negative 3 pi on 2. Over here will be negative 5 pi on 2. Okay. This one's going to be interesting. We don't have a lot of room, so it's going to be kind of tight. That's all right. So, sine of 0 is 0. I would draw a little unit circle up here. As we go to pi on 2, we're here. Left and, sorry, because we're doing sine, it's up and down. And so we are up 1. So let's call this 1. Mark that there. So we are here. Beautiful. Keep coming around to pi and we're here. How far up and down are we? Because sine is up and down. We're not up and down at all, so we're 0. And that's here. And then we keep going. No, we don't, because this is pi. And so we're done for the positives. Let's do negatives now. So as we come back, negative pi on 2. How far up and down are we? We're down 1. So we're at negative 1. And so this, we're going to need to mark in negative 1 here. Good enough. Negative 1 at negative pi on 2. And then we keep coming around to negative pi. And we're here, and there's no up and down, so we're back to 0. And then we keep coming around. Now we're up here, and it's the same as pi on 2, which was at 1, because we're up by 1. And so negative 3 pi on 2, we're here. Fantastic. And now this gets a little bit crowded here. So you can just draw another one somewhere you have space, not where it's going to interfere with the graph. But I think we can see enough here. We keep coming down, now we're here. Now we're at this bit, and we're not up and down at all. And so we go like this, and you might start to notice the pattern. This next one. So like we went here, down, 0, up, 0. This has to be down. And you can verify it on here. Negative 5 pi on 2, we were here. We go an extra 1 to get to here. And so we're down negative 1 again. And then we keep going over here. 3 pi would put us here. And not up and down at all, so we're 0. You can also follow the pattern, right? 0, down, 0, up, 0, down, 0. All right, now let's join the dots. Here it doesn't really matter because now we have everything laid out. I'm still just going to start with the positives. Like that. And then just join these with curves. Doesn't have to be perfect, just needs to look like a curve. Although I must say this one Here's some of my best work today. Yeah, that could use some work there. Okay, that's the answer to that one.